So moving on to the next question in this series of Get 2025 electrical solutions from control systems, subject control systems, is question number 57 from the master question paper of 2 marks, an A-type question from the topic chapter root locus. The question is as follows. Question number 57, 2 marks in detail. There is a closed loop system given in the figure as very simple unity figure. Is given as R of S, output is given as C of S, and the open loop transfer function G of S is given as k times s square minus 2s plus 2 upon s square plus 2s plus 5. This is given as G of S is given as this one, and the root locus of the closed loop system is to be drawn. Root locus of closed loop system for, as you all know, this range. Okay. So it is asked the question: angle of departure between 0 degree and 360 degree of the root locus branch drawn from the pole -1 plus J2 in degrees. This is an 85 question of 2 marks, and this is the question nearest increasing. So basically, an open loop transformation of forward path transformation is given. Unity feedback. We need to find the we need to draw the root locus, and from that we need to determine what is the angle of departure of the root locus branch originating from this pole. So let's identify the closed loop, open loop zeros and poles first. Open loop poles are given by s square plus 2s plus 5. We can write what? S plus 1 whole square minus 4 is equal to -1 plus minus J2, and zeros, open loop zeros are given by what? S square minus 2s plus equal to 0, numerator equal to 0. So this -1 whole square equal to -1, or s equal to 1 plus minus 0. So basically these are the open loop poles and zeros. What we will find is the angle of departure at this pole. Taking a plus sign, that is -1 plus J2, we need to find the angle of departure at this pole. Okay. Now we have a very commonly known and popular formula for angle of departure. Angle of departure at any pole is given by what? -180 degree minus contribution from other poles and zeros. As we know what? The contribution from all poles and zeros at the root locus point will sum up to -180 degree. So if you want the contribution of any particular pole, so what will you do? contribution of other pole, let's say phi minus contribution of that pole, say phi departure, okay, should be equal to minus 180 degree. From here what we can do? From here we can take this phi departure that side and it will be phi departure will what? Be what? 180 degree plus phi, the contribution of other poles. So it will be 180 degree plus contribution of other poles. And let's say phi c. Contribution of other poles will constitute contribution from the other poles and zeros, of course. Contribution from this pole as well contribution from these zeros. Contribution of the other poles and zeros, phi c will include contribution from this pole, contribution, the angular departure at this pole will include contribution from these poles as well as contribution from these zeros. So let us calculate one by one. Angular departure, angular contribution from this pole will be what? Just put here, you can write this g of s as what? G of s we can write it in factor form as k times s minus 1 plus g, s minus 1 minus g, by s plus 1 plus j2, s plus 1 minus j2. Simply put this term over here, over in this expression. So g of minus 1 minus j2 gives what? For checking this, we have to multiply, we have to remove this term, of course. So if you remove this term, the contribution will be what? Let's write it down. K times minus 1 minus j2 minus 1 plus j1. So it will be effectively minus 2 minus j1. And other one will be minus 1 minus j2 minus 1 minus j1. So it will be minus 2 minus j3. So minus 2 minus j3. Or what we can do, we can directly substitute minus 1 plus j2 in this one only. So minus 1 plus j2 gives minus 1 plus j2 minus 1 plus j1. So it will be minus 1 plus j3, right? Right? You put minus 1 plus j2 here, it will be minus k times minus 1 plus j2 minus 1 plus j1. So minus 2 plus j3. And if you put minus 1 plus j2 in this term, you get minus 1 plus j2 minus 1 minus j1. So minus 2 plus j1. So, okay. And to remove this, this one is the same as minus 1 plus j2. So you are not considering this. You put minus 1 plus j2 in this, you will get, this time you will get minus 1 plus j2 plus 1 plus j2. Minus 1 plus 1 gets cancelled and you will be left with j4. Right? So angle of what? Unit angle of s minus j2, s plus 1 minus j2 into g of minus 1 plus j2. Angle of this will be phi. So phi will get what? Angle of this whole thing. So it will be what? Minus 2 plus j3. Minus 2 plus j3 is in which quadrant? Minus 2 and 3. So it will be second quadrant. Second quadrant means it will be 180 degree minus tan inverse 3 by 2. So it will be 180 degree minus tan inverse 3 by 2. After that, what we have to do? Take the of this term. The angle of the argument of this term, that will be minus 2 plus j1. So this point. This was this point, zeros. So this is minus 2 plus j1. Minus 2 plus j3 was this point. Minus 2 plus j1 will be this point. So it will be again plus 180 degree minus tan inverse 1 by 2, right? Tan inverse 1 by 2, and J4 will contribute minus 90 degree because it is 1 by J. J is 1 angle 90 degree, so it will be minus 90 degree. So effective contribution is what? 180 plus 180, 360 minus 90 is 270 plus this tan inverse 3 by 2 plus tan inverse 1 by 2, 270. Okay. So tan inverse minus 270 minus tan inverse 3 by 2 minus tan inverse 1 by 2. 90 plus 180 360 minus 90 is 270, 270 minus tan inverse 3 by 2 minus tan inverse 1 by 2. So if we calculate, we will get the total of the addition sum of these tan inverse 3 by 2 and tan inverse 1 by 2 as, I think, 82.75 degrees, something like that. Tan inverse half plus tan inverse 3 by 2 will add up to 81.75 degrees, such that this term phi will be equal to 270 minus 82.5. So that is 187.25. Right. 187.25. So if you substitute over here, what we will get? 180 plus 187.25. Is effective what? 367.25. We know what? Angles repeat in multiples of 360 degree. So what we can do, we will subtract 360 degree from here, as the angle asked for is should be between 0 and 360 degree. So it is same as 360. 7.25 minus 360. So it is 7.25. So the angle of departure at this pole, the root locus at -1 plus j2 pole is 7.5 degree. Asked the nearest integer, so it should be 7. Now let's cross check. Let's show the root locus. Okay. The root locus here. Is there explained? This for verifying or cross checking purpose. As I have already found the answer correctly as 7. 7 ऑलरेडी हम लोग को मिल चुका है, बस आप लोगों को फिर से हमें क्रॉस वेरीफाई या क्रॉस चेक करना है ये देखने के लिए कि हमारा आंसर वो सही है कि नहीं है। क्योंकि एनईडी टाइप क्वेश्चन है तो कोई ऑप्शंस का रेफरेंस भी नहीं है, गलत होगा हमें पता भी नहीं चलेगा, इसलिए एक बार क्रॉस चेक कर लेना बहुत जरूरी है आखिर में। ठीक है, तो पोल्स का क्या लोकेशन है, जैसे हमने निकाला था अपने पोल्स का लोकेशन है -1 प्लस माइनस j2, तो -1 इधर हो गया प्लस माइनस j2 इधर हो गया माइनस j2 इधर हो गया। These are the poles and zeros का लोकेशन क्या है 1 प्लस माइनस j1, 1 इधर हो गया j1 इधर हो गया माइनस j1 इधर हो गया। So this will be this, right? Now what will the root locus? As you can see that there is symmetric, right? And there is one pole, there are two poles on the left of the S plane and two zeros to the right of the S plane, and in a symmetric, located in a symmetric manner. These are the zeros and these are the poles. So what we can say that the root locus branches will start originating from the poles, open loop poles, and terminate the open loop zeros. A equal to 0, A equal to 0, A tends to infinity, A tends to infinity. A very basic अंडरस्टैंडिंग, बहुत ही आसानी से हम लोग इसको रूट लॉस कैसे बना सकते हैं। ऐसे होगा ना कुछ रूट लॉस, कैसा होगा, ऐसा होगा ना कुछ इस तरह से होगा कुछ सिमेट्री मेंटेन करते हुए ओपन लूप पोल से स्टार्ट होगा और ओपन लूप टाइम हो जाएगा। ठीक है, तो इसको हम लोग देख के हम लोग को इस पोल पे एंगल ऑफ डिपार्चर पूछा गया है, इस पोल -1 प्लस j2, राइट। तो हम लोग देख के क्या बता सकते हैं, ये तो हॉरिजॉन्टल लाइन है, हम लोग बेसिकली ये एंगल पूछा गया है। ठीक है, सो इट विल बी समथिंग like this, बेसिकली हम लोग क्या पूछा गया, ये एंगल पूछा गया, ठीक है। ये एंगल बेसिकली हॉरिजॉन्टल, ये जो एंगल बना है इसका डिपार्चर, तो व्हाट यू कैन सी इज दिस एंगल इज वेरी स्मॉल एंड पॉजिटिव, क्योंकि एंटी क्लॉकवाइज सेंस में जा रहा है, हॉरिजॉन्टल से हम लोग एंटी क्लॉकवाइज जाना पड़ेगा इसलिए, तो स्मॉल पॉजिटिव, तो हम लोग को जो एंगल है वो स्मॉल एंड पॉजिटिव मिलना चाहिए। पॉजिटिव क्योंकि एंटी क्लॉकवाइज सेंस में ले रहा है, रूट लोकस ऐसा कुछ हो रहा है, ये दो ब्रांच है रूट लोकस का, और स्मॉल पॉजिटिव है इधर दिख रहा है, एज इट कैन बी ऑब्जर्व। सो एज वी हैव गॉट आंसर 7, इट इज मैचिंग बोथ आवर I mean it is matching both our what to say, what we actually expected, both our expectations. तो दोनों जो हम लोग उम्मीद किए थे दोनों से ये मैच कर रहा है, तो आंसर इसका होना चाहिए 7. So I hope this solution is clear. I have tried to explain from the very basics of root locus, angle of departure, how to calculate angle of departure at any given pole by going step by step, opening with poles, opening with zeros, finding angle of departure, contribution from other poles are calculated, contribution from other poles, the process I have shown, and so finally I'm putting get 360 and as 360 I am subtracted, it is 7.5, and the nearest answer is 7. तो हम लोग इस क्वेश्चन को बहुत आसानी से सॉल्व करते हैं, आंसर होगा 7, हम लोग का नियरेस्ट आंसर. सो दैट्स ऑल फॉर दिस क्वेश्चन.